Hi guys, in this video I'm just going to show you a simple demonstration in working with the Xamarin PCL, or the Portable Class Library, for iOS and the Android. So I have Visual Studio Community RC here. Let's just create a new project. Let's call it Stopwatch. And then make sure to create the blank app, SAML, and then PCL. And then just click accept. So this process will create some standard set of code for you, where you can begin with your work. So we'll create 3 projects since the version 27 RC. It will create the iOS, the Android, and the portable class library. So I also will be quickly opening up the VMware for the Mac. I now have the Mac on the left side of the screen here. After the project is created, we'll try to build the project if it works. So make sure to choose iPhone Simulator, then the project name .ios to build this project, and then choose the model that you have already open in the simulator on your Mac. So if you have a physical Mac and then you've started a certain simulator, choose that. And then for my case, I'm going to choose iPhone 5s iOS 10.2, and then just click on start here. So it will then try to build the project. I think it should be building on the C# side and then sending that data to the Mac, and then the Mac builds on the Xcode side and then builds everything else. So here we get the welcome to Xamarin Forms. So this is the application at this point. So let's also let's stop this, and then let's try to build for the Android. Let's set it as the startup project, and then here I'm gonna choose this one because I have already opened this up, the simulator. So for some reason it's faster if you open the simulators before rather than opening the simulator because of a build. So since this is the first time to build the Android app, this may take some time, but it should be faster on the Android because on my PC it's on Windows and accelerated version. So here we have a similar output. So if you open Stopwatch and compare it, so welcome to Xamarin Forms, and here on the right side, welcome to Xamarin Forms. So what I'm going to do next is let's stop this, and then the hardware, let's go to home. What we are going to do next is try and modify the portable common library, PCL, and then here in the app.xaml, this is where the common resources are stored. So at this point we're not going to work with that. The main page.xaml is a layout of type content page. So essentially this is a class, and it inherits the content page class. So the code behind for this XAML is this one. So it's a partial class called main page. This is also the XAML for that. They have the same file name, and then it inherits content page, which is a standard layout, Xamarin.Forms content page layout. So here in the main page, I'm just gonna create. So this is just a regular C# class. So in order to create a simple stopwatch, what you're going to need is a simple UI. So for the UI, we're going to work with stack layout. So stack layout is simply allows you to put multiple labels. So in order to demonstrate the difference, I'm gonna put two labels here, and I'm gonna render it on Android. So I'm just gonna mark this as label 1 for its text, and this other one is label 2. So the SAML file holds the UI design, much like the HTML for web development or hybrid development. So the SAML file holds the actual controls, and this XML is then converted to their native counterparts. Like the label is going to be converted to the standard label for Android, and the other one for iOS. So the expectation is we should see label 1 and 2. So if we start the Android simulator, we see only label 1. So what happened was that the content page rendered label 2 first, then for some reason it got overshadowed by label 1. In order to fix that, we're gonna need some layouting. So in order to implement a stack layout, you're just gonna need the stack layout like that, and then put these two labels inside. So if you run that again, we should now see label 2 and label 1, one after the other, so they're on top. But if we try this on iOS, if you change the build to iOS and then choose the device as iPhone 5s, this one, and then rebuild on iOS, it's always a good strategy to always test on both the iOS and the Android, because sometimes your UI does get messed up because of the different platforms, how they treat the UI elements, because don't forget these are converted to native elements. So as you can see here, the status bar on the top is being overlaid by the label 2, which we have here. So what we're going to do is do a little styling. So in order to implement that, I'm gonna stop this simulation and then add some padding to the content page. So one way to do that is through properties. So in this case, we are essentially calling out the padding field of content page here, content page that padding, and then on the platform iOS we get this, and on Windows Phone we get this. So more details on that is on the Xamarin website. So essentially they are changing the thickness of the padding. So that's it. What else? So I'm also gonna add some spacing, and then here let's add some spacing. Let's probably do a 10, and then name this as layout main. So this is going to be our main layout for this content page, and then within that we have two elements. So let's check on the iPhone the effect of these UI changes. It does take some time to transfer all the code to the iPhone. So we now have a padding of 20 units on top of label 2, which we have here, and then a spacing of 10 for label 1. So 1 and 2 is separated by around 10 units. So what else can we do? We'll try adding some buttons. So we're gonna need to be able to stop, start, and reset the stopwatch, and we're gonna need to show the time. So let me just stop this and then put in some buttons. what I have already pre-written a few buttons here. So for example, we have a name for this header. So essentially, the name for the header is how you can reference this on the code behind file. So in order for us to be able to reference this on the code behind, we need to put a name. So we have here the header, the elapsed time, and then the button start, button stop, and button reset. So let's try this code out. So it should be pretty obvious what these attributes do. Vertical option center, horizontal option center, and then the name is for referencing, and then the text is the actual content of the label. So this should be quite understandable. So it's very similar to writing HTML. So as you can see, you can't see the label elapsed time. What you can see is only the label header where it shows the text time. So the reason for that is that there's no text for this label, so it is essentially an empty label. But you can already click start, stop, and reset. That's so let's try to check how this looks like on the Android. So let's switch to Android, and then let's, yep, this is the correct simulator. So what we have so far is the UI for starting, stopping, resetting, and the label here, start, stop, reset. So this is typical Android UI. Okay, that's good. Stop this one, and then let's try to add in some code. In the main page.xaml, which is this file, we have the code behind file in C#. So once again, just a regular C# file that works with the XAML. I'm just gonna add in a few fields here. So in the initialize component, as you can see, we have 3 buttons here. Since we already assigned names for them, you can actually copy this, and then in the xaml.cs, in the code behind file, you can then type that, and then boom, you get the autocomplete. So on the click event, you're just gonna add a event, and then you can do anything at this point. So let's reference all those so that we can work with them on the code behind file. Okay, and then click, press tab, press enter. So we now have a function call for these 3 clicked events, and then of course, since we will need to initialize the stopwatch, so let's try and initialize that using the new keyword that we get fresh object, and then so now we have a stopwatch, right? So if the user clicks on start, if the user clicks on start, the user should be able to start the stopwatch. So you would also only want to stop this stopwatch if it's already running. So this object already has is running. So we're just gonna put that inside an if, and then stopwatch that stop. I mean, I was referring to stop, so stopwatch that stop. You're gonna call that, and then also if you wanna start it, so you don't really need to start the stopwatch if it's already running. So if the stopwatch is running, so I have negated that with the exclamation mark. We want to start it. So I'm just gonna put these at the top. So start, stop, reset. That's it. So you can reset anytime. So stopwatch dot reset. Of course, if the stopwatch is paused at some point, so you can just reset it back to 0. If it's running, you can reset it immediately back to 0 without doing anything else. So this is what we have so far. Start, stop, but we have no way of showing this to the UI at this point. You have no way to know if it started, it stopped, or it has been reset. The only way to know that really is to show the changes on the UI. So one way to do that is to create another thread which takes care of showing that to the user. So we can create this thread here using the task. So but I prefer to create it here in the initialization. So what this does essentially is while true, this is an infinite loop. We're gonna need to put this in a task. So what we have here is a lambda expression that puts certain code within it. So I'm just gonna explain this. So the updater, which is a task, you just wanna create a new task, and then it creates a task and then starts it immediately. So what's inside the task is it's an infinite loop that works on a different thread, not on our UI thread, but on a different thread. So that's why first we have to, for every loop, we have to wait at least 10 milliseconds at least, so that we don't press our phone, and then the device that begin invoke on main thread is a simple call that forces a certain action which you can place here that will work on the main thread, on the UI thread, because you don't want to call an update of the UI thread from a different thread. Basically, the background thread do not have any knowledge of the elements on the UI thread because they're on a separate thread. They have separate memory allocation in terms of what they know in terms of scope. So what you're gonna do is you are going to force the device to invoke a certain action from a different thread to the main thread. So we're gonna update label elapsed time. So this is where we put the current time, and then we're gonna update the text, and we're gonna use a very simple string interpolation, this one. So what it does is it just gets the value as stopwatch, elapsed total seconds, and then format it to get only the integer part, and then stopwatch at elapsed milliseconds and get the milliseconds for the current second. So that's it, in using only 3 whole number digits, using only 3 yeah, like rounding off the 1000. So because these are type double, this one is int but this one is double, so you're gonna need to watch out for that. So I think this completes the entire code, to be honest. If hopefully if this works, so let's try on Android. So now it's built on Android, and if you're going to check you're gonna click on start, it does start, and then click on stop, it stops, and then you're gonna click reset, it goes back to 0. So one way to check if your code is working is you're gonna put breakpoints in these areas, and then if you create start, as you can see, it's turned yellow here, and then you can go on and review the breakpoints. Press F10 to run around and just click continue. So now it started. So if you press start again, you can see if you press F10, it immediately goes here. It doesn't start the stopwatch because it's already running. That's it. So in order to fix that, we're gonna disable some of the buttons here. So let's try and do that. Let's stop this. Then let's go to the buttons, and then on the button start, what you have to do is just disable the start button, disable the stop button, disable the start button, and enable stop and reset. And also in the stop, you're just gonna do the opposite, and then also here. So if you click the stop button, you can reset, but if you click reset, you can no longer reset or stop because you're at 0. You can only start again. Click on start. Okay, let's disable all breakpoints temporarily, and then click stop, so you can only start or stop and can only reset. And then start, stop, reset, start, reset, start, stop, reset. So that's it for the Android part. Then let's try on the iOS if it works well. Let's move to stopwatch.ios, and then on the device, let's select 5S. So what we have here is 5S, and then I think it's pretty good. Let's start the simulation. So it will then send this new code back to iOS. Click on start, stop, start, stop, start, stop, reset. So I think it's pretty good. We have all the requirements on the iOS, and it seems it's able to function quite well, similar to our work on Android. So I think this is it. So on the next few videos, I'm just gonna show you how to create a list view, wherein every time you reset or stop, that particular time is added to a list view, so that you can at least check the history of when you started and when you stop or resetted the app. So that's a fine addition to this simple app that we're creating. So we'll be following on that on the next video. Thanks for watching.